Hello and welcome to Chapter 6. In Chapter 6 we're going to be talking about binomial probability distributions. Chapter 6 is a relatively short chapter, but there is a lot of information to cover. So let's get right in. So in Chapter 6 we talk about binomial random variables, calculating binomial probabilities, cumulative probabilities, probability calculators, expected value and variance of a binomial random variables, and using the binomial distribution to help make judgments. So, getting to binomial random variables, a binomial is a family of discrete random variables. Remember, discrete being like concrete, it's an actual value that you can count. It's not a continuous random variable. Binomial random variables is the random number of successes in an n-independent Bernoulli trials. So a Bernoulli trial has two possible outcomes, either a success or a failure. It happened or it didn't happen. Right? You can also think like heads or tails. It's either heads or tails. Binomial random variables have two parameters, n and p. N being the number of trials and p being the probability of successes of each trial. So let's get right into an example here. You may have seen this one before. Consider the random number of successful treatments when treating 4 patients. Suppose the probability of success in each instance is 75%. The random number of successes can vary from 0 to 4, right? Either 0 people are successful or all 4 people are successful. The random number of successes is a binomial with parameters n equal 4 and p equaling 0.75. So this is the notation where we let x, and this tilde symbol we read as distributed. So let x distributed b for binomial of the parameters n and p. So we'd say the variables x distributed binomial probability of 4, 0.75, where 4 is our n and 0.75 is our p. So how do we calculate this? How do we calculate binomial probabilities? So the formula for binomial probabilities is as followed. Probability of x is equal to n c of x times p to the x power times q to the n minus x, where the nc of x, the binomial coefficient, we're going to talk about this in the next slide, p is the probability of successes for each trial, right? We just talked about that. And q is the probability of failure, which is equal to 1 minus p. So remember, the binomial probabilities has two outcomes, right? It's either a success or a failure. And p is considered our probability of successes, and q is the failures. Or if you're thinking about it, 1 minus p, that's the complement, right? It's everything that isn't a success, it's a failure. It's the complement of it. So, the formula for binomial coefficients, the very first part, n c of x is equal to n factorial divided by x factorial times the quantity of n minus x factorial. So, where this little exclamation part is the factorial sign calculated, and the way you do factorials is you take x times x minus 1 times x minus 2 times all the way down. The way this kind of looks, probably an easier way to do is if you take 4 factorial, it's just 4 times 3 times 2 times 1, which equals 24. That is 4 factorial. And by definition, 1 factorial is 1, and 0 factorial is also equal to 1. If that is confusing you, I recommend going on Google and typing in. You can find and read and watch videos about why this is so. But if we just go by, just know the definition of 1 factorial is 1 and 0 factorial is also 1, which you have probably learned previously. So here's an example where we have 4c2, where 4 is our n and 2 is our x. So we have 4 factorial divided by 2 factorial factorial times quantity of 4 minus 2 factorial. And when you solve this out, you get 2 factorial, resimplify it, and resimplifying it even more, writing it longhand, equals 6. So 4 choose 2 is equal to 6. Now, here's that same problem again. The binomial coefficient is called the choose function because it tells you the number of ways you could choose x items out of n. So NC of x is the number of ways you choose x items out of n. So for example, we have 4 choose 2 is equal to 6, which means there are 6 ways to choose 2 items out of 4. And just another illustrative example, say you had 4 friends and you wanted to take them to the movies. Let's call our friends Bill. My handwriting is horrible on here. So we have Bill, Bob, Jill, and Jackie. And these are your 4 friends, and you want to take 2 of them to the movies. Well, how many different possible combinations are there to take 2? Well, you can take Bill and Bob. You can also take Bill and Jill, and you can also take Bill and Jackie, and that's 3 possible combinations, right? But you can also take Bob and Jill and Bob and Jackie, and that's 2 more possible combinations, and the last one is you just take Jill and Jackie. And so if you were to add up all the combinations, you get 6. Now this is a very kind of simplified way to show it, but as you get into higher numbers, when you have maybe like 50 or 60 different possible outcomes, this is the formula for figuring out for binomial coefficients. So we call the 4-patient example the one we went over a couple chapters ago and just previously brought back up. The 4-patient probability of successes in each treatment is 0.75. The number of successes is the binomial random variable of x distributed as b times 4 comma 0.75, where 4 is our n number and 0.75 is our p, the probability. And then we note q is equal to 1 minus 0.75 is equal to 0.25, right? Remember, q is the complement of p, and remember we said q equals 1 minus p, and p is our 0.75, so 1 minus 0.75 is equal to 0.25. So what is the probability of observing 0 successes under these circumstances? So here is our equation, and I am going to set this up now for us. Remember, we had our x distributed b times our n, which was 4, and the probability 0.75. And what we're trying to solve is now x equaling 0. So to set this up, we're going to just walk through it slowly. Our NCX, right? Well, our n is 4. Choose x, which is right here, which is our 0, times our p, which is 0.75, to the x power, which is 0, times q, which we calculated as 1 minus p, which is 0.25, to the n, which is 4, minus our x, 0. So I'm just going to write this out one more way. So our how many different ways can we choose 0, 4 for our choose function? And that'd be 4 factorial over 0 factorial times 4 factorial times 0.75 to the 0 power multiplied by 0.25 to the 4th power. So this is our equation set up. When we figure out our choose function, these guys are going to cancel out. And our 0 factorial, by definition, remember, is 1 times anything to the 0 power is 1 times 0.25 to the 4th is 0.0039, which equals 0.0039. So the probability of binomial probability of n is 4 and probability of 0.75 at 0, the probability of getting 0 is 0.0039. Here we continue on if we wanted to figure out the probability of 1 and 2. Same steps, putting in our n and x's all the way across, notice them, and then just working the steps out slowly every time. So your 4 is always your n, your x is 2, x, and minus x. Keep working out, so the probability of 1 is 0.0469, probability of 2 is 0.2106. Here's 3 and 4. And continuing on, we go and here's, this is in figure 6.2, the cumulative probabilities corresponding to the area under the curve to the left of the value. This PMF shows the cumulative probability of 3 for x, binomials n equals 4, probability 0.75 in tabular and graphical form. So this we have seen before in the book. These are the probabilities of success for 0, 1, 2, 3, 4. And here's the graphical representation of it. And so if you wanted to know the cumulative probability of 3 successes, this is the shaded area all the way to the left. And the way you do that for the cumulative probability is you add up the cumulative probability between 0 and 3. And if you add that up, you get 0.6836 for the cumulative probability there. So area under the curve, recall the area under the curve, the ACU concept is the probability. Once again, just it's just kind of like a rectangle, base times width, and we know that the height is 0.2109 and the width is 0.1, and the area underneath that is 0.2109. Cumulative probabilities, I'm actually going to stop here and pick this up in the next part and hopefully finish it out. So I'll see you at the next video.